Hello students, so today we will solve these 5 questions of chapter chemical and ionic equilibria of chemistry. So let's start and let's solve these 5 questions. So we start with the first question, which says which of the following is not a conjugate acid base pair. So for determining which is the conjugate acid base pair, you should know what is the characteristic of a acid base pair. So a conjugate acid base pair, there should be a difference of only one H plus ion. So difference of only one H plus ion, that is the property or characteristic of a conjugate acid base pair. So if a pair has a difference of only one hydrogen ion or one H plus ion, then you call it a conjugate acid base pair. So let us see which of the 4 options given in the question have only difference of 1 H plus. So first question that has HClO4 and ClO4 minus. So you see there is difference of only 1 H plus, so it is a conjugate acid base pair. Similarly second one, HSO3 minus and SO3 double minus, again there is a difference of only 1 H plus between these two species, so they are also conjugate acid base pair. In the third category C, there are 2 species H3O plus and OH minus. Here the difference between these two is not of only 1 H plus, but there is a difference of 2 H ions, because here you have H3 and here you have only 1 H, so there is a difference of 2 hydrogen atom difference is there. So this is not a conjugate acid base pair, so this will be the correct answer. We can verify the third one also. Third is H2O and OH minus. So again there is a difference of only 1 H plus ion, so it is also a conjugate acid base pair. So the correct answer to this first question is among these 4, this H3O and OH minus, this is not a conjugate acid base pair. Okay, I hope you understood this question. Now let's move to the second question. So this is your first question. Now we are coming to second question. Second question says, in which of the following formulas does the oxidation number of oxygen differ than in other formulas? So here you have 4 compounds, NO, NO2, H2O and H2O2. So actually this is a kind of question you should remember this, like what different oxidation states are carried by oxygen atom. So all these first 3 options, first 3 choices here, they are normal oxides. So this is these 2 are nitrogen oxides and this is oxide of hydrogen. So in the oxide state, oxygen is bonded with 2 other atoms which are different in the terms of electronegativity. So in the oxide cases, the oxygen is having -2 oxidation state, and that is the most usual oxidation state of oxygen. But the fourth one here, this is peroxide. And what is peroxide? In peroxide, the oxygen atom is bonded with one another oxygen atom, and the other 2 free valencies are bonded with some other atoms. Like here they are bonded with 2 hydrogens, so 1 H here, 1 H here. So here these 2 oxygens are same, so there will be no electronegativity difference between these two. So only electronegativity difference is coming between this atom and this atom. Because of that, the oxidation number here oxygen gains, that is -1 and -1. So this is a special thing about peroxide ions. In peroxide a bond, oxygen has the oxidation number of -1, and this is different than the other 3 choices. So the correct answer for the second question is fourth one, H2O2 has a peroxide bond or peroxide linkage. That's why its oxidation state or oxidation state of oxygen will be different here than the other 3 compounds where oxygen is present just in the form of oxide. Okay, so now we are coming to the third question. Third question is, which of the following has the lowest and highest pH value respectively? So third question is, we have been given 4 solutions or 4 species: household ammonia, lemon juice, milk of magnesia and milk, and we have to determine the pH of each of these. So first one is household ammonia. So for that household ammonia, you have the POH given. So POH is 2.10. That's why you can calculate here pH, because you know the sum of pH and POH is always 14. So pH can be calculated as 14 minus POH, which is 2.10 here. So if you subtract this, 10 minus 1 will be 9 and 3 minus 2 will be 1 and again 1. So 11.9, that is the pH of household ammonia. Second is the pH directly given for lemon juice, so we don't have to do anything here. It is 2.37 and this is your lemon juice. And third is OH minus concentration is given, so you can calculate POH here. So POH is defined as minus log OH minus H. pH is defined as minus log H plus. Similarly, POH is defined as minus log OH minus. So let's put the value and calculate this. Minus log OH minus concentration for the milk of magnesia is given as 3.2 into 10 raised to the power minus 4, and let's calculate this, and we can use a calculator to calculate this. So minus log 3.2, let me write it, minus log and 3.2 into 10 raised to the power minus 4, right? And how much it is? It is 3.49, or simply you can write 3.5. So that is the pH of, sorry, this is POH, right? This is POH, so you can calculate pH again as 14 minus 3.5. And how much this will be? 14 minus 3.5, 10 minus 5 will be 5, and this will be 3 minus 3, 0 and 1, so it is 10.5. And the last one is milk, where H plus ion concentration is given. So this was your milk of magnesia, and last one is milk, for that H plus ion concentration is given, so you can directly calculate pH as minus log H plus. Let's calculate this. Minus log H plus ion concentration is given as 3.2 into 10 raised to the power minus 7, and let's again calculate this using calculator. So minus log 3.2 into 10 raised to the power minus 7, right? Minus log 3.2 to 10 to the power minus 7, so it is coming 6.49, or simply you can write 6.5. So 6.5 is the pH of milk. So now you can compare all these and all these four. So the last one is the milk, right? So this is milk. So you can get which is the highest and which is the lowest. Out of these four values, you see that 11.9, that is household ammonia, that is the highest value, having highest value of the pH, and this lemon juice, which is having 2.37 pH, that is the lowest among these. So the lowest pH is for lemon juice and highest pH is for household ammonia. So let us see which is the correct answer. It is the first one, right? Lemon juice and household ammonia. You have to mark here lowest and highest pH value respectively. So first you will write lowest, then highest. So lowest is lemon juice and highest is household ammonia. And if you notice, this is also intuitive, because lemon juice is a juice, lemon has citric acid, so it is acid, so it will have like low pH, and ammonia is basic in nature, so it will be little higher in pH, but you need to compare it with the other given options. Okay, so for the third question, the correct answer is A. Now we are coming to the fourth one. So fourth question is, what is the molarity of H2SO4 solution if 74.30 ml of 0.4388 molar NaOH solution is needed to neutralize 45.78 milliliter of the acid? So let's do this question, fourth one. So here you are considering the neutralization reaction of NaOH and H2SO4. So how it will happen? H2SO4 plus NaOH, they neutralize each other to give sodium sulfate Na2SO4 and plus H2O. But if you balance this reaction, because this is not balanced, you need to put 2 here, it will be Na2SO4 and it will be 2H2O. So you see here that for every mole of H2SO4 you require 2 moles of NaOH. So here it is given that how much NaOH you have, 74.30 ml, 0.4388 molar NaOH. So this is information given about NaOH, and this neutralizes how much? 45.78 ml H2SO4, but you don't know what is the molarity. So let's say its molarity is X. So if you know the definition of molarity, what is molarity? Molarity is number of moles divided by volume of solution in liter. So if you have to calculate number of moles, how can you calculate number of moles? It will be simply product of molarity and volume. So if you multiply molarity and volume in liter, that will be number of moles. But if volume is given in milliliter, then that will be number of millimoles. So you can calculate number of millimoles here, number of millimoles of which species? Of NaOH, because for that you have been given the volume and molarity both. So it will be 74.30 multiplied by 0.4388. Similarly, you can calculate number of millimoles of H2SO4 also. So its molarity is not given, but we have assumed that is X, so you can multiply these two also. So X into 45.78, this is the number of millimoles of H2SO4. But from the equation you know that for H2SO4, number of moles of H2SO4 must be double of number of moles of NaOH. So here number of or you can say that number of moles of H2SO4 will be half of total number of moles of NaOH. So number of moles of or millimoles is this. So half of this will be half of 74.30 into 0.4388. So this is the number of millimoles of H2SO4, and that we already have written as X into 45.78, or from here you can write X as 74.30 multiplied by 0.4388 divided by 2 times 45.78, and from here you can calculate X. Let's use the calculator to make the calculations easy. So it is 74.30 multiplied by 0.4388 divided by 2 into 45.78, and let us see what this value is. This is coming 0.35608, or you can write 0.3561. So X is here 0.3561 molar, and this was the molarity we considered of H2SO4 solution. So X is 0.3561, which we considered the molarity of H2SO4. So correct answer is 0.3561, which is the first answer. So the answer to the fourth problem is A, 0.3561 molar. Okay, now we have the last question left. Let us see how we will do that one. So last question says, which of the following aqueous solutions is acidic? So let's find. So first answer, okay, so first let's the H plus ion concentration is given, that is fine. So for this solving this question you can do it directly also. So if you know for a neutral solution, concentration of H plus and OH minus, this is equal, actually this is 1.0 into 10 raised to the power minus 7 molar. So this is the concentration of H plus and OH minus in a neutral solution, and if H plus is less than this, then the solution will be basic, and if H plus ion concentration is more than this, then the solution will be acidic. So let's see each of the four options given here. First is H plus concentration is 4 into 10 power minus 4. So if you know 4 into 10 power minus 4 is much larger than this 1.0 into 10 to the power minus 7 molar. So it looks like a acidic solution, but let's check other options also. In solution B, OH minus concentration is given 10 power minus 7. So if OH minus concentration is equal to 1 into 10 power minus 7, that is the characteristic of a neutral solution. So solution B here, that must be a neutral solution. Now let's come to C, solution C. There OH minus concentration is given as 1 into 10 power minus 3 molar. So again you see this value is much larger as compared to the OH minus concentration in the neutral solution. So here OH minus concentration 1 10 power minus 3 is much larger than the OH minus concentration this one. So OH minus is much higher, and if OH minus is higher, then the solution is basic, not acidic. So this is a basic solution. And solution D, let's check that also. Here H plus ion concentration is 1 into 10 power minus 13 molar, and if you compare this with this value, so 1 into 10 power minus 13 is much smaller than this value. So here H plus ion is concentration much smaller than the concentration of H plus present in the neutral solution. So H plus is very small, so this cannot be acidic solution, because in acidic solution the H plus ion concentration should be much larger than this. So you find that only the first option here, that has the H plus ion concentration much higher as compared to the H plus ion concentration present in a neutral solution. So correct answer will be first one, A. So option A is the correct answer for question number 5. So I hope you understood all these 5 questions, and if you like this video, then please consider liking it and share it and subscribe my channel also. So thank you very much, take care and bye bye.